Hello everyone. Welcome to this training session on statistical data analysis using Excel. As a part of this session, let's focus primarily on the concept of random numbers and why do we need to use random numbers as a part of the statistical estimation processes, and at the same time how do I generate these kind of random numbers using tools like Excel. So these are the various aspects which we will look at in this particular topic. What do you mean by a random number? Any value which has randomness in occurrence is what we call as a random number. Right? Let's say I talk about the height of people. If I take one person at random, his height can be anything. Depending on the person whom I have chosen, his height can be anything. Anywhere from 150 centimeters to probably 200 centimeters. So, whatever the randomness that is present, what we are saying is, especially in our statistical estimation process, we require the usage of samples. Based on the sample only, we make some kind of conclusions about the population or some kind of inferences about the entire population. So, for that standpoint, the sample which we are using for our computational purposes, it should be as much random as possible. Right? How do you ensure the randomness? That is where, let's say our population is the entire 1 lakh people in a particular city or in a particular village. I want to take some 1,000 of them and I want to measure their heights. So that 1,000, I want it to be as much random as possible. Otherwise, my conclusions regarding the overall population's height and all would be very much biased. So to ensure that I select the 1,000 out of 1 lakh in a completely random manner, I'll take the help of the systems to generate the random numbers for me. Right? So that is what is the context. So as a part of our estimation process, we get into the sample creations or sample selections, and to make our estimation as much close to reality as possible, it is necessary that our sample should be as much random as possible. And that is the context in which we have to understand the random numbers. So random numbers as such can be generated quite easily in Excel. Right? So let's see how we can generate those random numbers in Excel. There are two major formulas in Excel which will help us in generating the random numbers. Right? In this sheet I will generate the random numbers. So if I say a formula called RAND, R-A-N-D, this is the one that generates random number. Some number between 0 and 1 is what it generates. On a random basis, it generates the value which lies between 0 and 1. So, probably if you look at this, I can generate, if I simply drag it, I can generate as many random numbers as possible. Let's say I am generating 100 such random numbers. So all of them will have the values lying between 0 and 1. and there is no particular format in which these numbers are obtained, there is no particular algorithm in which these numbers are obtained. They are completely random. Of course, internally the system uses a separate algorithm to compute these values, but as an external user, I see that they are completely random in nature. I cannot directly establish a pattern between these between these numbers, and by default you will see that these numbers are following a kind of uniform distribution. What do we mean by uniform distribution? Even if I take a small interval, let's say I do a frequency distribution or using the pivot table, right? The easier thing is I'll go for a pivot table of this just to show you in what pattern these numbers would be generated. Right, I'll go for a pivot table here itself, but of course I'll delete it off after that because that is not the intention for me. So let's say I select the data here and also select the count also here and probably group it. Right, I say a group selection based on 0.1. Now what you see that almost all these numbers are uniformly distributed. Between each of the groups you find almost 10, 10, 10, 11, 13, somewhere in the same range itself. That is what we mean by uniform distribution. If we have seen earlier when we talked about normal distribution, we said that when I plot the frequency distribution curve, it comes like a bell curve. But here it looks as if we are plotting a straight line kind of stuff, horizontal line, because across all the places it is looking like 10 itself. So overall it looks like a flat line in this kind of example. So which means the simple way for me to analyze, let's say if I am refreshing it, even after I refresh these things, I'll see that the numbers are not that drastically different. Right, the numbers, probably I should refresh it here. Alright, but whatever may be the case, we are seeing that the percentages are much across all the board, across all the values, across all the ranges, the proportion distribution is more or less uniform. That is what we call as a uniform distribution. So a formula like RAND can actually help us in attaining this kind of So probably let me remove off this pivot table because we really don't need it at this moment. The only reason why I have to show it is to show that the random numbers which are computed, they follow a kind of uniform distribution for us. Alright. Now there is another, if I don't want the values between 0 and 1, but I want it in a specific range. Right, between 10 and 20 you generate some integers which are random numbers. In that case I cannot use the RAND formula. I will use another formula called RAND between. There are two formulas which Excel has supplied for randomness. So if I say RAND between 10, 20, right, some number between 10 and 20 is generated at random. Right, so there are some 20s, 10s, 11, 17. Again here all the values between 10 and 20 have more or less equal chance of occurring. Right, so depending on if I want the values between 0 and 1, because generally what happens is people generate the values between 0 and 1 and assign that to be the value equal to probability. If they want to generate a normal distribution curve from the existing data, what they'll do is, whatever the random number that is generated, they assign it as a probability under the normal distribution graph. So based on that, they do a reverse calculation to obtain the value. We'll see some of the mechanisms now. How do I generate a random number which is not a uniform distribution? Let's say I want to generate a random number which follows a normal distribution rather than a uniform distribution, because the simple rand and rand between kind of formulas, they generate a random number which would typically follow a uniform distribution itself. But let's say I want to generate random numbers following a normal distribution, right? We'll talk about other distributions slightly later, but as we have already discussed about the normal distribution, I can talk about the random numbers that can follow a kind of normal distribution in this case. So what I can do for that is, in the data, as a part of data analysis, I have something called random number generation process. Okay, I'll use that random number generation. For how many variables you want the random number to be generated? Let's say only one variable, the heights. The height is something for which I want to generate the random numbers. And how many numbers you want to generate? Let's generate some 1000 numbers. Fair enough. And the distribution, what kind of distribution? Uniform is something which is already generated, but you can generate using normal, Bernoulli, binomial, all these kind of distributions. We'll talk about some of these distributions slightly later, but normal is something which we have already talked about. So I can say I want my data to be created based on a normal distribution. And then I can also give what are the mean and the standard deviation for this data. Okay, if I say the mean height is around 170 centimeters and the standard deviation in the heights, let's say, is around 10. It's basically like, even if I don't have my data, if I just have the two attributes of that data, which is like, probably some note somewhere which says the heights of the Indian males follows a normal distribution with a mean equal to 170 and standard deviation equal to 10. Even without having the raw data, what I can very well do is I can do a reverse engineering and generate the data using this process of random numbers. And then we have another aspect called random seed. What this means is some starting point. If I don't give any starting point for the randomness, you can give any number of your choice. If I don't give anything, every time the value gets repeated, every time the value gets randomized. But if you want to generate the same set of random numbers again and again for your different analysis, it's better to give a random seed to the random numbers. Probably let's say some 10,000 is my random seed. Some number where I would like to start off, or 10,001, whatever it is. And you can also say where do you want these values to be displayed. Alright, so let's say that let them be displayed in this E column. So let's see what it comes out. So what comes out to us typically is a set of random numbers are generated. You see at the bottom it is saying calculating the random number generation process. So the random numbers are getting generated, and here you see that these are the random numbers. Now, almost 1,000 such values might have got generated. It looks as if you have gone to 1,000 people and taken their heights. Right, without having the data, we have generated the data. Now you see almost of 1,000 people you have generated the data. Right, without actually going for 1,000 people and collecting their height. The moment you know that the mean is 170 and standard deviation is 10, my system is able to generate the values which lie between, which lie in that region, which can give me the mean of 170 and standard deviation is 10. So just to check out, alright, let's try finding out a few things here. The mean, where I can use the average formula. The mean in this data is 169.65. We have said that it is 170. We have taken the assumption as 170, so almost matching the mean. Right, the standard deviation, let's see what it is. The standard deviation 10.33, we have said is 10. So it is able to generate the data as per our requirement. And first of all, can I know whether it is normal or not? We have talked about too many mechanisms on how do I check for the normality in the data. Okay, let me try out the skewness. Right, okay, the skewness in this data, how much is it? My skewness, the skewness in the data equal to skew. The skewness in the data is around 0.07, very close to 0, which is an indication of the normality. Even let's check out for the kurtosis in the data. Kurtosis in the data is also minus 0.36, again closer to 0 itself, which is an indication of the normality again. And we have also discussed about mean should be equal to median if it is normal data. So let's see the median also in this case. 169.57. You see, mean and median almost matching together. That again indicates that there is a huge normality present in the data. Or probably I can also try finding out the IQR, compare it with 1.33 times the standard deviation. So probably I'll go with quartile 3 minus quartile 1. This is IQR, whereas 1.33 times standard deviation is almost 13.74, slightly different here, but at least the mean, median, they are equal, skewness, kurtosis very close to 0. So overall it can indicate the normality that is present in the data. We have generated a normally distributed data without having the data, using this concept of random numbers. So that is where the random numbers will play a big role for us as a part of the analysis, because most of the times we have to take a sample of data to do our calculations, to do our estimation process. And the better way to generate the sample, the more the random the sample is, the better it will be useful for my analysis. The better it will bring out the estimates and predictions as a part of my analysis. The more the biased is my sample, probably there will be a lot of error between the actuals and the predicted values to a great extent, or the reliability of the model will be a big question mark. So from that standpoint, what we are saying is, if at all my sample has to be really random in nature, how do I make sure that the sample becomes random is to generate random numbers which don't have one specific algorithm in terms of generating the values. So there is an equal chance for every item in the population to be included into the sample. So that's the process of random sampling, right? Especially if my population is huge and I have to select a sample which is more and more random, I can use either the rand formula or rand between formula, or probably I can generate an appropriate distribution distribution with the data. I can go as we have done right now. I can use the data analysis the pack to generate the random numbers belonging to normal distribution or uniform distribution or few other distributions also. I hope this session has given you some level of insight into the understanding of the concept of random numbers, how to generate random numbers in Excel using the formulas as well as the data analysis tool pack, and what is the prime need for generating random numbers as a part of our statistical estimation process. If you have any more further queries regarding this, feel free to get in touch with me by giving me a call on the number which I have specified below, or drop in an email at vamsidhar@pacegurus.com. I would be very much comfortable in replying back to your queries. Thanks a lot for listening to this session. Thank you very much.